Hello everybody and welcome back to the second set of problems. The first one, what's the acceleration of a car that goes from 20 kilometers per hour to 30 kilometers per hour in 1.5 seconds? A follow-up question at the same acceleration, how long will it take to go from 30 kilometers per hour to 36 kilometers per hour? We're given the initial velocity as 20 kilometers per hour and the final velocity as 30 kilometers per hour. And again, time 1.5 seconds. Using this relationship, we have acceleration is equal to v minus v sub 0 all divided by t, which will be 30 kilometers per hour, subtracted by 20 kilometers per hour, all divided by 1.5 seconds. This gives us 10 kilometers per hour divided by 1.5 second, which is equal to 6.7 kilometers per hour per second. So that's our acceleration. We can take that and use that in the second problem, or second half of the problem, and say the time it takes will be the difference of the velocities divided by the acceleration. So it'll be 36 kilometers per hour. Subtract from that 30 kilometers per hour. And we'll divide that by 6.7 kilometers per hour per second. We get in the numerator 6 kilometers per hour. We'll divide that by 6.7 kilometers per hour per second. And our answer, 0.9 seconds. And that's the end of the first problem. The second problem, a car starts from rest with an acceleration of 5 meters per second squared. We're asked to find the velocity after the vehicle's traveled 600 meters. A is given as 5 meters per second, and the distance S is 600 meters. We're asked to find velocity. We can use a relationship down in the bottom. V is equal to, should be an equal sign there, the square root of 2 times the acceleration, 5 meters per second squared, times 600 meters. That'll be the square root of meter squared, second squared. The units come out as, and then we've got 6,000, so that's 6,000 meters per second squared. We can break that down into the square root of 60 times the square root of 100 meters per second. The square root of 60 is about 7.7. Square root of 100, of course, is 10. So 7.7 times 10 meters per second, or 77 meters per second. And the problem is solved. The third problem, an airplane must have a velocity of 50 meters per second for takeoff. We're asked to find the acceleration it must have if the runway length is 500 meters. We're given velocity as 50 meters per second and the distance as 500 meters. And we're asked to find A. We'll be able to use the same equation we used in the last problem. And here V sub 0 is equal to 0, which is why we can use V is equal to square root of 2AS. We rewrite that as v squared is equal to 2 times acceleration times the distance. So we get an equation for the acceleration of v squared, or speed squared, divided by 2 times the distance. Substituting numbers in, we get A is equal to 50 meters per second squared divided by 2 times 500 meters. This is equal to 2,500 meters squared per second squared divided by 1,000 meters. So our answer is 2.5 meters per second squared. The fourth problem in this set, a car accelerates at 8 meters per second. How long will it take to reach 24 meters per second starting from rest? And how far does it go? We're given A as 8 meters per second squared. V, the final velocity, 24 meters per second. Starting from rest means V0 is equal to 0 meters per second. We're asked to find T. And we can use the second formula. A is equal to V minus V sub 0 divided by T. We rearrange that to solve it for T. We have T is equal to V minus V sub 0 divided by A. Here, V again, 24 meters per second. V sub 0 is equal to 0 meters per second. A, the acceleration, is 8 meters per second squared. 24 divided by 8 is 3. So the answer would be 3 seconds. And then using S is equal to V sub 0 T plus 1/2 AT squared, and keeping in mind that V sub 0 is equal to 0, we have S is equal to 1/2 AT squared, which is equal to 1/2 times 8 meters per second squared times 3 seconds squared, and all of that, when you punch in the numbers, 8 times 1/2 is 4, 3 squared is 9, 9 times 4, 36. The answer is 36 meters. Our last problem in this set, a car with an initial velocity of 20 meters per second is accelerated at 5 meters per second squared. We're asked to find how long it will take to reach a velocity of 50 meters per second and how far does it go. So as given, V sub 0 is 20 meters per second. The acceleration, 5 meters per second squared. We need to find the time. We're given a final velocity of 50 meters per second. And we're asked also to find the distance. Using the equation that we've used several times before, we have V, or T, is equal to V minus V sub 0 divided by A. So it's 50 meters per second. Subtract 20 meters per second. Divide that by the acceleration, 5 meters per second squared. And we get 30 meters per second divided by 5 meters per second squared, which is equal to 6 seconds. To find the distance, we use our distance formula. S is equal to V sub 0 T plus 1/2 AT squared. When we substitute our numbers in, we have 20 meters per second times the time, which we just found to be 6 seconds. We add to that 1/2 times the acceleration, 5 meters per second squared, times our time, 6 seconds squared. When we do the math, we come up with 210 meters as a value for the distance.